I'm Katie Judge, and I'm going to explain the physics of flight. There are four main forces acting on a plane in flight: thrust, drag, lift, and weight. The thrust is generated by the plane's engines pushing it through the air. Drag is the force of air resistance that counteracts some of the thrust. The weight of the plane is the force of gravity pulling the plane down toward the earth. To properly calculate the weight, not only the weight of the plane needs to be considered, but the weight of the fuel needed for the flight, passengers including the pilot and co-pilot, and any cargo being brought onto the plane. For safety, the center of gravity must be kept within a design-specified range. The fourth factor, lift, must be generated to counteract the force of the weight. Lift is generated by four things: deflection, Bernoulli's principle, the Coanda effect, and circulation. Deflection is caused by the wing of the plane pushing down on the air, and through Newton's third law, the air pushing back on the wing. This interaction causes the wing to move up, generating lift. This effect can be seen when you blow on the bottom of a piece of paper. The force of the air blowing pushes the paper up. Bernoulli's principle deals with pressure differentials and explains that when a section of air has a lower pressure, then air molecules from other sections of air rush in to fill the gaps. The principle is used to generate lift in aircraft and can be seen when you blow air over the top of a piece of paper. The lower pressure made by the air flowing over the top of the paper allows the air below the paper to rise, bringing the paper up with it, or in a plane's case, bringing the wing with it. A third factor of lift is the Coanda effect. The Coanda effect is a principle explaining the tendency of fluids to go around the surface of an object. You can see this effect firsthand by putting a spoon in a stream of running water. You'll notice that the water redirects itself around the edge of the spoon. The same idea applies for airfoils in a stream of air. The airflow redirects itself around the edge of the airfoil, causing the airfoil to rise. The last factor is circulation. Circulation is sort of like a combination between Bernoulli's principle and the Coanda effect. This explains the air flowing patterns redirecting themselves around both the top and the bottom of the wing, causes the pressure both above and below the airfoil to drop. But because the top of the airfoil is more dramatically curved, a lower pressure system still develops above the wing, allowing Bernoulli's principle to take effect and the wing to rise. In order for a plane to get off the ground, all of these factors must be considered, as well as atmospheric conditions and the specific design of the plane. It's plain to see that flight is a complicated science. Thank you for listening.